Please welcome Joseph Sirosh to come on stage here. Thank you. Thank you.
Thank you very much. Yeah, I did. Can all hear me? Great. While we're waiting for the slides. So I've been a machine learning geek now for quite a while, since '95. My first job was building credit card fraud detection systems using neural networks at a startup company in San Diego called H&C Software. It was about neural networks that sat in the authorization stream of credit card transactions and scored every swipe for the probability of fraud. It was a real-time system, and it made a dramatic impact in the world because it was able to close the loop completely. It was not just about detecting something interesting, but it actually drove action and real-time action. And what you're really seeing in the last 25 years is that type of technology that is closing the loop between data, intelligence, and real-time action and taking feedback and continuously being improved really start to blossom. At the end of the day, you may call it AI, but it really is all about data-driven, intelligent, predictive action and systems of intelligence, right? So if we can go to the, but it's become a tidal wave. And I think it's happened at the intersection of the major revolutions that happened in the last 3 decades of the cloud wave, of the digitization of the world, of AI algorithms, all of them coming together in a very, very unique way. And that's what I'd like to talk about a little bit. So first, I want to start with a story. To either side of me is a timeline of the Earth. It's 4.5 billion years long. And as you follow that timeline, I want to call attention to Earth's 4 billionth birthday. That's when life on Earth started to have a party. Let me explain what I mean. That's the start of the Cambrian Explosion, or the Cambrian Acceleration. Before the Cambrian Acceleration, all the life on Earth was single-celled, maybe collections of a few cells. And then in a short 80 million years during the Cambrian period, all intelligent life on the planet, all precursors to complex, intelligent, reasoning life emerged. And scientists have been wondering why. What happened in 80 million years? What was so unique about that time period? Well, there are explanations of various types. There was more oxygen in the air and a number of things. But one of the most intriguing theories advanced is the emergence of distant vision, the ability to see at a distance. So you might ask the question, why does the ability to see drive such a dramatic change in a short time period? And remember, the ability to seeing is not about just registering pixels on a retina. It's about understanding what's in it. And when a creature is able to understand what's in its environment, it becomes a better predator. And if it becomes a better predator, then the prey has to evolve extremely rapidly to survive. And then when the prey evolves very rapidly, the predator then in turn has to become very capable, evolve nervous systems to reason, evolve various ways of moving and catching prey and so on, now because you have a smarter prey. And this sets off a cycle of competitive evolution that completely accelerates the cycle in a dramatic way. And every type of body plans emerge. Nervous systems to reason with the data emerge. And ways of new senses being brought together with the existing senses emerge. And it makes life dramatically more richer, complex, and diverse. OK, so what's the parallel? We are at a similar moment of an AI acceleration happening in the world of software and technology. The parallels are very, very similar. Until now, really, computers were all about collecting a large amount of data, registering in systems of record, and allowing you to program against it. The future is very different because now you have, for the first time, the ability to understand what's in that data, reason with it, take action, making you a dramatically more effective economic entity if you are an economic entity. And then in turn, the economy of the world itself changes. The competitive dimensions change. And the data you collect and reason with and how you actually run the economy itself changes. That's the acceleration that's happening. And that's what the motivation for the work that we do is at the end of the day. So these revolutions are happening today at the intersection of the three most important trends in computing. The trend in the cloud, and in many ways, sort of the cloud is an ocean in which AI is born. The cloud changes the way software is built and delivered. It makes software a utility. You provision hardware through software, software becomes services, and then data aggregates in the cloud in ways on top of which you can build intelligence and reasoning. And intelligence, in turn, becomes a utility on the cloud. Then the access of data, the digitization of every type of data, and there is a virtuous cycle, by the way, just as Deepak Agrawal was saying, between AI and data. AI is not just built on existing data, but because you can do AI, you're going to collect new data, and you're going to instrument systems that allow you to solve problems in very unique ways by applying AI. And that's very powerful. In fact, one of my favorite stories actually comes from Japan. This is, by the way, the sexiest story in the cloud and AI, I'm telling you. It's Fujitsu. Fujitsu has actually created a cloud-connected pedometer for cows in Japan. And dairy farmers in Japan have deployed pedometers for cows. Data from those pedometers is coming through the wire to a service in the cloud on Azure, Microsoft's cloud, called the Cow Step Service, GUHO. That's what it's called. So do cows need to take 10,000 steps a day? What do you think it's for? Well, maybe more. Well, take a step back. It turns out every company turns out to be a data and AI company, even the most unexpected ones, even dairy farms. See, dairy farms have a very fixed, a small number of things they can optimize. They have a fixed pasture, they have a fixed herd, they have some expensive farm labor, and their output is milk and beef. So you've got to optimize that output, milk, under all of these constraints. So what's a dairy farmer to do? He has really two primary controls. He can ensure that the cows are healthy all the time. And second, that you never miss a cycle of conception. Because if you miss a cycle of pregnancy, the cow may not produce milk for a month. Okay? So it turns out cows go into heat only about 18 hours in a 21-day period. And like all natural processes, these things are very highly variable. And they tend to go into heat at inconvenient times, like at night, 10 to 8 p.m., and farm hands have lots of other things to do. For millennia, what farmers have done is really to recognize visual signatures of the cows go into heat so they know when to mate. Well, what do you do when you have thousands of cows in a dairy farm and very expensive labor? How do you know when the time is right, when the magic is about to happen? Like, can you build a heat map of the dairy farm, so to speak? Well, so that's sort of the question that a dairy farmer asked Fujitsu. And they consulted a bunch of veterinary researchers. They came up with this ingenious system. They found that if you analyzed pedometer data, you could actually get a very accurate signal for when the cow is going into heat. The secret turns out to be actually quite simple. It turns out when the cow goes into heat, it starts walking around furiously, maybe like some of us. The number of steps it takes spikes in a big way. And so that turns out to be a very accurate signature for the onset of heat. And the optimum time for artificial insemination turns out to be about 16 hours from that. That's when you get the maximum probability of conception. That's when AI meets AI, artificial insemination, that is. And you find that, like, they found really amazing things in the data. They found that if you performed artificial insemination the first 4 hours before that optimum time, you could get a female calf with 70% probability. And if it was in the next 4 hours, you could get a male. And now, so you had a sort of a probabilistic control of the gender. And then they went on and researched the data. They found they could find about 8 different diseases of cows by analyzing the step count because of different patterns of listlessness and so on. And then it didn't stop there. Remember I said this was about 95% accurate? The remaining 5%, some of that turns out to be important too, because some of that's when the cow actually jumps the fence and runs away from the farm. You're going to detect that too now. So what I want you to gather from that is this amazing closed loop. So you instrumented an IoT device to measure a behavior that had never been digitized before. You created a service in the cloud that analyzed it and predicted something. You closed the loop by sending an alert to the mobile phone of the farmer, and then the farmer optimized that process of ensuring that the cows never miss a cycle of pregnancy and you have conception all the time. They got about a 33% improvement in milk productivity, by the way, out of that. That loop is what AI is all about in the enterprise. Okay, so I wanted to show you one other really powerful example. This was an application created for autistic children by one of our partners. Is an ISV called Codex. So at a higher level then, think about this. What AI allows you to do is understand every type of data at a deep level, just like human beings do. Every type of data, media, and IoT sensor data, and everything else. It allows you then to really reason with that data to take the right action and do so at incredible scale and automate things that were never before automatable and invent new business opportunities as well. And then third, it allows you to interact with human beings in ways human beings are used to interacting and automate away a lot of the drudgery that otherwise exists in the world. Those are three major themes. And so let me tell you a few more customer stories because I think these are illustrative. So on the left at the top, Unilever. Unilever has created a conversational bot internally for all of their HR, finance, and support functions. It's a very large organization, multinational, and a big part of their digital transformation strategy is to create intelligent bots for every type of function internally so that when employees interact with these systems, trying to find information, getting guidance, onboarding new employees, all of that's automated. So Rolls-Royce on the right, it uses Azure machine learning to predict failures of jet engines coming from the telemetry so they can optimize scheduling of service. Cochrane does systematic reviews of medical literature so they can really group together the publications for every particular type of disease and recommend the right treatments to doctors. And they help. They use text analytics extensively to help themselves automate the process. Publicis uses a number of face analysis technologies to recommend the right makeup for Sephora. Jabil uses deep learning-based automated optical inspection of printed circuit boards for detecting defects. Portland Trailblazers uses machine learning to engage the first-time visitors to their games and bring them back in again. And they find significant lift. Hendricks Motorsports races cars with machine learning. They're able to predict when the car is going to run out of fuel and have enough tire wear that requires a pit stop, so they can run a race with the fewest pit stops. And they've been racing cars with machine learning for a year. The Snow Leopard Trust based in Seattle, a very interesting story, by the way, helps conserve snow leopards in the Himalayas. Snow leopards range over very, very large area in the Himalayas across 11 countries, and they have camera traps to actually take pictures of them and do automated image recognition of snow leopards versus all other animals that come, and then do census. Pretty powerful. So here's what then these companies are doing. Every one of them is really a system of intelligence. I talked about this closed loop that is being executed between data, AI, and then action. And I wanted to show you one more scenario of that kind of a closed loop. eSmart Systems, okay, a startup in Norway. They've got a connected drone. Now here is an example of a tedious task. Inspect thousands of miles of power lines for when the power line is going to fail. So what they have there is a drone with a camera flying over all these power lines, taking images, vast amounts of imagery, deep learning then being used to identify issues with connectors. They can actually spot the specific connectors in all these power lines and then predict whether that particular part is going to fail. Automates another one. So their technology became very useful right after Hurricane Irma for inspection of all of the power lines down in that area. And again, I want to show one video because this use case is another interesting one to see.
We got called down here by a utility company in Florida after Hurricane Irma, actually on our way from Hurricane Harvey down in Houston. So we drove over here and we are assessing the damage that Hurricane Irma caused on in the Florida area.
The client that we have here in Jacksonville is JEA, and so far everything's gone very well. It's interesting using cutting-edge technologies such as drones with cutting-edge technologies such as these mobile command centers that eSmart Systems brings to the table.
In conjunction with them, we are giving real-time live stream information back to basically anybody back at the utility.
Their data analytics are seamlessly integrated to the Microsoft Cloud and are able to create actionable intelligence for the end users.
The biggest way it benefits the community is to basically bring power back as fast as we can. So that eliminates a linesman climbing up the lines or anybody basically going into an area that's not safe. Drones allow us access to areas without putting a human in harm's way.
The UAS use case is safety, and being able to have an eye in the sky in a place where you wouldn't be able to safely put a manned aircraft, or you wouldn't be able to safely put a human on the ground to, say, inspect something in a traditional method.
As this is the safest way to give this post-damage assessment for the utility companies.
So being able to provide new types of data intelligence to an end user.
The data that we give to the company is all geolocated, so it's a very simple way for operators in the office to direct the linesmen of where they need to go fix and what parts they need, the crew that they need to get the power up as fast as possible. And this can all be done in real time.
It's great to be able to bring some sort of new type of relief to a disaster area such as where Hurricane Irma hit in Florida.
By the way, shortly after Hurricane Irma was a earthquake disaster in Mexico. You can imagine a scenario where every type of disaster management can be actually assisted by AI of one type or the other. Very, very powerful. And here, there's an architecture here of that cloud-connected system. I won't walk you through all of the details here, but it was actually, what's powerful about it is, today AI systems are being assembled in the cloud by composing services that exist in the cloud. The assembly of that and having a real-time system live for you, available in any part of the world to interact with, that's actually really possible and it can be done in very agile ways. And the thing is, think, for example, the benefits of something like this. A drone isn't flying around all the time and doesn't require compute resources in the cloud all the time. The elasticity of the cloud allows you, when you deploy the drone, to actually scale up your compute and your AI in the cloud. Use all of that power when you need it, and then you shut it down later. And there are lots of other benefits. The availability of the latest hardware, such as GPUs, FPGAs for inferencing, and so on, that enable these kind of scenarios with the power of the cloud. So the key takeaways here, by the way, when we as Microsoft interact with our customers, we find a few things. We find that all of this exciting technology, it's actually very hard for enterprises to access. Building systems of intelligence are actually kind of hard. It's an end-to-end integration of infrastructure, data, AI, actions, and feedback. And I want you to imagine the situation on premises without a cloud today. Right? It can be any cloud versus on-premises, a huge difference. Where if you're going to assemble lots of pieces of software from lots of vendors, try to hook them up, try to install them in lots of servers, connect them up, have expertise in every one of them, and try to build a highly available, elastic, real-time system with all those vendor software. How hard is that going to be? It is incredibly hard. What the cloud allows you, when you have services for all of these, with a very common programming model, with very easy ways to compose all of them, with elasticity, with all the monitoring, telemetry, the failure management, all of those things, is it allows you to build these systems of intelligence by just composing Lego blocks. And that's very, very powerful. So, but then customers also want the following. We find that customers want a strategic partner for their systems of intelligence. It's not easy to understand the architecture, even if the cloud supports all these services. And we also find this other thing. People want well-engineered platforms, not consultant-built solutions. The vast majority of AI, by the way, today is actually consultant-built solutions. IBM, Accenture, and those. I mean, they're potentially great partners, but consultant-built AI is brittle. Data changes, systems change, the services change, services that actually supply data to the AI systems change. How do you cope with all of that change without now having that perpetual long-term relationship with the person who built that? Very hard. That's why, again, well-engineered solutions are required. And so that's what informs what Microsoft is doing. Microsoft's AI platform is really all about bringing the power of the cloud and AI together in ways that are extremely well-engineered and allows you to build robust solutions and monitor them. It's really best of cloud to AI and best of AI to the cloud. It's really the join of the two. So we have higher order services for AI. We have the infrastructure on the cloud to support all of these use cases, and tooling to build applications. So let's double click into that a little bit. Services. We focus on three major areas. Conversational AI, well, which the bot framework, because we believe natural ways of interacting through bots is going to be a fundamental enabler of the digital transformation. And it allows you to automate and empower things that were not otherwise doable. Then you have pre-built AI, which is called cognitive services. And this is an important thing. Look, people don't, for example, build or engineer buildings these days from the ground up with brick and mortar, unless you are in some remote parts of the world. People assemble buildings from prefabricated parts. That's why, for example, you all probably all heard about the hotel that was constructed in China. They constructed in 6 days and restaurant the 7th day because it's built out of prefabricated parts. A lot of AI is going to be like prefabricated parts. And you're going to be assembling systems of intelligence as opposed to building deep learning systems from the bottom up. And by the way, I want you to think about it this way. We're all used to having millions of apps on an app store on a phone. Why wouldn't there be a million APIs hosted in the cloud that you can compose? And a cloud vendor, by the way, will stand behind those APIs. It'll give you SLAs, it'll give you trust, it'll give you identity, it'll give you security, all those kinds of things. And then your application development, and remember, by the way, APIs are far more powerful than apps. Application development will then be composing APIs to build those systems of intelligence. And that's what the direction of pre-built AI is all about. By the way, pre-built AI is not just about algorithms. It's about data, expertise, algorithms all coming together. Nobody builds a speech recognition systems today from scratch with deep learning. There is a lot of sophistication to building a speech recognition system. So you'll have speech recognition, translation, vision, all types of things built with expertise, algorithms, and data available to the builder. And that's what the pre-built AI will be. And then now, not all use cases are going to be served by pre-built AI. That's when you have a platform like Azure Machine Learning that allows you to build from bottom up, from data all the way up, and create, by the way, APIs, more APIs hosted in the cloud that can then be composed with the rest of it. So when you actually build a bot, you might use some speech recognition and language understanding and a few of those, but you will also probably use Azure Machine Learning to build some APIs custom to yourself, put all of those things together and orchestrate them. And then, by the way, then into the infrastructure level. So all of these at the top really layer on top of the powerful databases, data warehouses, analytical systems, and distributed compute available in the cloud. And for example, the cloud will provide data warehouses. We announced, by the way, a couple of months back, a great partnership with Databricks. And we have an Azure Databricks as a service. We would be thrilled to use that as a platform to build AI on top of it. We'll have data lakes. Then even more things like Azure Batch AI, for example. Azure Batch AI allows you to to harness like very large number of VMs and just use scheduled jobs and potentially at 1/5 the cost with spot pricing and use that for training AI. And then the Edge support, IoT Edge on Azure, allows you to deploy AI to the edge devices in factories and in other places. So it allows you to manage all of that. And underlying all of that is a vast amount of compute hardware, which is constantly innovating. Right? It's GPUs today, it's FPGAs tomorrow. Microsoft has a very big strength in the world of FPGAs. And in fact, all the Bing queries, query responses are served by FPGAs running machine learning models today. And then we supply tools. Rich variety of tools. Microsoft has had a great developer tools effort for a long time. Those tools come to help you build applications in the cloud. And we have a very open approach to all the innovation in deep learning and machine learning, in that we support a cognitive toolkit, Caffe, TensorFlow, all of those open source ones. And we actually, by the way, have partnerships working with Facebook, working with Amazon to create a common neural network exchange format called the One Neural Network Exchange format called ONNX, that every one of these tools can actually write to. So that becomes a common intermediate representation that can then be interpreted. NVIDIA just announced support for that recently. And what happens is here, now when you have a common representation of a deep neural network or a machine learning pipeline, then all the device manufacturers can go optimize against that. And that's very, very powerful. So this is our platform story. So now I want to show you an AI at the edge example. Now when you compose a cloud and the edge, and I want to actually do that through, again, a story. But let me skip this one. And I want to tell you this story. So we have a powerful application that we've been building with cognitive services. Microsoft has a number of these pre-built AI components. And this is the Seeing AI app. So again, a powerful assistive technology, best seen through the demo. It's really about helping the blind actually see with the power of cognitive APIs in the cloud. So to show you, let me just actually first play a video. There should be a video. Yeah, to show you what that is.
I'm Saqib Sheikh. I lost my sight when I was 7. And shortly after that, I went to a school for the blind. And that's where I was introduced to talking computers. And that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
And now I'd like to invite Anirudh Kaul, one of the developers of this very powerful app, to show this live.
So hi everyone. Seeing AI, the name already gave it away. It's computer vision and AI for whom? For the blind and low vision community. So every year we have this annual hackathon in the company where 18,000 employees participate from over 100 countries. We gave it a shot and we got some good results. We started working on this passion project and well, we have our day jobs out of it now. So that's good. So we originally started with basically a smartphone duct taped to the head. That's how we are like, in a very starting way. And from there, it manifested into a smart glass-like solution. And then we said, what can we do to get it hands of as many people as possible? And the way you do it is, well, you put it out in an iOS store as a free app so people can download it. And we did that 4 months ago. And we already have a few million use cases that people have come out with. So what this is really is a Swiss Army knife where you are running deep learning on the device or on the cloud, and it's doing certain things. Like what kind of things? You could be reading text, sorting your mail so it's either junk mail or is it like your bill. When you go to a shopping mall, recognizing products. When you're paying the cashier, knowing that that's a $10 note. When you are wearing clothes in the morning, knowing that that's a black colored shirt. Or when you get a note from your grandma, knowing that the handwritten text can be still read. Worst case is when you have a bulb and you want to know it's on or off, you don't have to touch a hot bulb to know it's on. So, let me quit yapping and just go into the demo mode. And I need a young volunteer here, if you do the honors. All right. I think we can see some. Yeah, let's give it a shot. So the first thing is, it's a person mode. It's trying to understand who's there. With some volume, it does. Let's give it a shot.
My job is to always look happy so the Nordstrom guys don't put me in the sales section.
Oh, OK. I have a. Can it play? OK, so it's supposed to have a voice. So I'll just enact what it's supposed to say. I'll have to take the thing off. All right, I'll just say what's going to happen. OK, so the moment, I think if you can see on the screen, what's happening is you'll have to see towards me. What happens is it starts to detect the person. It speaks the name. And on top, it detects the distance between the camera and the person. So it gives away who the person is. And then when you take the photograph, that's when it's a little more visual. The app will actually, now you can see there. Is it diplomatic or a little more aggressive?
It's more aggressive, but it's good enough. It's close enough.
Cool. So by looking at Hollywood movie scenes, it's basically able to recognize the emotion and the age.
In Bollywood, right?
Well, that's where we had to do work. And on top, going towards, you have a sunglass on, you have a beard, what is the color of your hair? It can give a really rich description. And that's a feature. How do you see it in action? Well, we have a salesman, a blind salesman in Thailand, who uses it with a bone-conducting headset so nobody else can hear what he's hearing. And he changes his sales pitch based on the gender and the age of the person he's selling it to. So that happens. We have users who put this phone on a desk. So whenever somebody comes into their room, they can identify the person from a decent distance away. And well, when we launched it 4 months ago, we started noticing blind users posting photographs on Facebook. Because now they could know that in a social occasion, they can take a photo of their friend, know he's in the center, and then know that they are smiling. So they don't want a frowny, bad quality photograph on Facebook. Yeah, nobody wants that, right? So that blind photographer is one example, which is like enabling because you have a feature like this available. By the way, the face training is actually done by users themselves on the app. So the data is on, like the training happens on device. So it's on the IoT side. So that's good. What else can we do? Well, you can recognize things like objects, and maybe give a description of the scene. So let's see if it works out. Let's read that. A group of people sitting in a room, right? If you start to visualize the heat map, you will notice that the bent knee is a good indication of that you are sitting, and obviously you have seats, and it does a description of not just objects, but verbs and their relationships. So if it can do that, it can also obviously do simple things. I'm not going to go too much in detail, but like reading text. Now, reading text in a video stream live and deciding when to speak and when not to speak, with that, people can walk around in shopping malls and with their phone on and hear descriptions of that's like this section or that section. I'm going to go to some fun things. Obvious things are OCR is OCR, but fun things. We heard people using it by putting the phone on a tripod, pointing it towards the television screen, and watching an entire movie in Mandarin because it was reading the closed captions in English. So that's like a common example we have seen, and many more things. So we have a bunch of different options for the kind of task you have at hand. We don't want to be God and say, decide the context as we were discussing before. We want to go like step by step, do a good job, and then eventually see where it goes. So that's the app. Now the question comes in, so that's limited to an app. What else can you do? Well, people would be using Twitter, Facebook, WhatsApp, other apps, right? And it would be a shame if you miss out the opportunity to make the rest of your phone accessible. So when you are on WhatsApp or Facebook or Twitter, you are discussing a conversation, and then somebody posts a meme with text and some fancy photograph. Everybody is laughing, but a blind person would miss out on that conversation. So we said, let's bring that whole thing back to the app. So all you got to do is take the photograph and share it, and it comes with a voice, by the way. Got to drop off my laundry and pick up my bone, and it says a dog sitting on top of a car. So it brings the people included in that conversation on what's happening, and that's a great use we have seen. To also show the value of the simplest of the possible AI in here, you won't hear it, but the simplest example is something in my hand, which I picked up. It's a container to most people, right? But this container, I don't know, it's Pepsi or Coke or 7-Up or root beer. I don't know, because it would be a container at the end of the day. And how do you recognize it? Well, one simple way would be this barcode, right? You scan the barcode, you know the object. But the problem is a blind person doesn't know where the barcode is to begin with, and barcode need to be right then and there. So we have shown the app thousands of barcodes, but not clean barcodes from angles, from different orientations, from lighting conditions. And now the next time you actually put the app, you basically just rotate the object in front of it, and the moment it sees the barcode, it will start to make some sort of a beeping sound. More the beeps means it's getting closer, 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 closer. And the moment it comes really close up, it will recognize it, and there you have the description. To do this previously, you had to buy a $1,300 barcode scanner. Today, people are selling those and making some money out of it because you can do it free on the device. And that's the power AI can bring. So finally, just to give a sneak peek, because everybody's revealing their secrets of how things are made, there's a presentation here.
And could you show with the audio? I think it's very powerful when you show the sound. You can just pull that off.
Yeah, I think the presentation does have audio in it. And it should be coming pretty, yeah. Oh, I should actually show you the audio because I have a microphone on. All right.
Person, product.
All right, you can hear it. All right, so I have basically a Coke can. As it starts moving, and you start hearing these beeps. So you start basically bringing the beeps closer to you, and
Coca-Cola Zero Cola 0 144 FLOs.
Not to drink today, but that's how you will basically hear the beeps, and it's the intersection of UI and UX in AI in the same place. Now, when we were building it, we needed photographs, right? More photos, better it goes. But not clean photographs. We need dirty photographs from the real world with bad lighting conditions. So we asked our fellow employees, hey, guys and girls, can you give us some photographs? So we built an app to do that called Edify. And as you can see, we told them, get us dirty photographs, not the clean photographs you see on your search engine. So like in this example, if you have to train a currency, they would go around mashing up their phone left, right, up, down. That's not the kind of photos you see on the internet. You see nice ones. All right, so that's good. So then we started to send these photographs as a challenge of the best of the photographs people took last day. And they started to internally challenge to come up with the worst photographs they could possibly produce, like these, where things are taken off in context, or like this. And by the time we had the neural network training, we didn't even know that there are these small little patterns that you can pick up with occlusions that the neural network knows, and I, who has seen this thing for years, doesn't know. So this can get you, hundreds, tens of thousands of photographs, but not 100,000 photographs. Oh, OK, I need to set this up. So what's happening is, so we said, OK, how about we tell people to fool the neural network we just trained in the last step? So their job is to come up with an angle or lighting condition where the classifier mispredicts it, and you'll get a Mario point for it. And that's what people did. So you'll get a Mario point. From the top, it's working really nicely. But from this angle, it's misclassifying this. It's not able to predict it. Back from the top angle, it's working fine, no mispredictions happening. But from the side angles, it does, right? So with these adversarial examples, with a few thousand images, we are able to train what we would have needed hundreds of thousands of photographs. And that's why they say, keep your friends close and keeps your enemies, adversaries, even closer. So that's all the time I have, but you can check this out. It's seeingai.com. And thank you for listening to me.
Thank you, Andy. Awesome demo. Thank you. So by the way, what you showed the last time, it also speaks to AI drives you to create new data. So he's collecting new data, and it's all about creating the right collection of data to learn from it. So one of the things that Deepak Agrawal said is really important to remember. It's not about quantity of data. It's about quality of the data for the right problem, and setting all of that up. And I want to, I know I'm way over time, but I wanted to stop with just a couple of more examples, and then if you have time, please stay and I'll answer questions. I talked about bots. So we have a great bot framework, a cloud-hosted bot service called Azure Bot Service. But really the most important thing to understand about bots, it's not about the bot interface, it's about the bot brain, right? So the bot brain is what really adds the speech recognition, the language understanding, that does the dialogue management. It searches when necessary. It allows you to structure the Q&A. It allows you to do workflows through, say, if interfaces, right? If then else. Machine translation, and so on. And then it also allows you to do task completion. So don't think of bots as just question-answer systems. Bots are most useful when you are actually getting something done by the bot. The bot actually completes a workflow much faster. That's super important to understand, and has to do it optimally. So I want you to step back and think about a future where every task has an API. That's a place where we're going to. Look, there are APIs to turn on lights and turn off. You can get lots of things done through APIs. You can book things and so on. There's a future coming not too far out where every action has an API. And then how do you invoke those APIs to get the tasks you want done? That's what bots are going to enable you to do. So again, bots are dumb today. Everybody will agree. But it's going to be incredibly useful because they'll be able to do things for you. Okay? And by the way, there is an interesting discussion going on in the world today about, are you going to have the Alexa and Google Assistant and Cortana kind of bots that are consumer bots? Or are you going to have enterprises create their own bots? A very interesting thing. And I think it's a very open question. By the way, we're seeing a lot of customers, enterprise customers, who are creating bots not only to interact with consumers, but to change their internal workflows, to help their field service agents, and a number of other things where it's really all about custom bots, and the assistants really have no role. Okay, so click once more. So I want to stop on this slide, and one more thing to share. So Microsoft AI platform's capabilities today, that you can build systems of intelligence with the power of the hybrid cloud. It's very open. It allows you to compose all the power, vast amounts of, you can do data wrangling, big data, GPUs. You can deploy anywhere on the IoT edge, on the phones, all of those supported by a great, powerful platform. And one of our theses is also, by the way, that one at the top, that vast amount of AI that will happen in the world, it'll be invisible AI. It might be actually optimizing milk production in a dairy farm in Japan, or it might be doing fraud detection in credit card workflows, or it might be doing marketing targeting and so on. The economic fabric of the world is going to be infused with AI, and it will dramatically change the way the economy itself works. And that's the opportunity for an AI platform player. Today, we can also build visible AI, build cognitive applications, and back to the previous page. I don't know why it went, it's moving. So you can also build conversational AI, and it's using pre-built services. The capabilities are going to keep improving, NLP, vision, speech, and many other things, and conversational systems, very, very powerful. But the world is going to be fundamentally transformed. It's the Cambrian acceleration brought to software. I think software of the future is going to be dramatically different as a result of AI from software of the past. Okay, that's our opportunity. So a couple of resources for you to look at. Next slide. So you'll see, if you can go to the azure.com/AI page, you'll see a lot about our platforms, and it's a continuously evolving collection of web pages. AI School gets you a lot of material to learn and train. And Microsoft's also supporting startups and accelerators in a big way. We have Microsoft Ventures and the Startup Accelerator that Ventures invests in startups. The Startup Accelerator helps enable existing startups on Azure and with AI. Lots of exciting things happening. And I wanted to share this one startup competition that's going on. This is driven by Microsoft Ventures with 4 partners and run in 3 continents. There is a $3.5 million pot. It's really for early stage startups leveraging AI, and it's being run in North America, Europe, and Israel. So the price is there'll be one winner in each region, $1 million investment, $500,000 in Azure credits for 3 years, Office 365 for 1 year, and free technical support. So there's more there. Please go to that URL, microsoftventures.com/competition. That's an AI competition for startups. So should be an exciting one. So with that, let me stop, and I'll be happy to answer a few questions.
Joseph,
thank you.